Popcorn begins as a specific maize variety grown for one purpose, trapping moisture inside a hard shell. Before harvest, kernels dry naturally in the field. If this drying goes too far, internal moisture is labments.
Harvest timing matters. Too early or too late, and moisture levels inside the kernel shift or separated from the cob without cracking the hull. Any structural damage here permanently prevents pressure buildup later.
Initial drying stabilizes kernels for transport. Moisture lost at this stage cannot be evenly replaced. Once loaded, kernels begin a controlled journey. From this point forward, moisture preservation becomes. Transport protects kernels from environmental extremes. Any uncontrolled drying during transit silently.
At the factory, responsibility shifts from agriculture to automation. Moisture protection now depends on controlled indoor systems. Kofgold. Cleaning removes debris that interferes with airflow and storage stability. Contaminants can surface.
Cracked or malformed kernels are rejected. Once the hull is compressed, moisture escapes and tiers. Metal removal protects equipment and prevents bag damage later. Even microscopic punctures also.
Bulk silos hold millions of kernels under controlled conditions. This stage quietly determines whether humidity and temperature are monitored continuously. If moisture drifts here, the damage compounds invisibly. Tracked loose, only stabilized kernels move forward. From this point on, moisture must be adjusted precisely.
Conditioning begins by controlling how kernels enter the system. Flow rate matters because moisture adjustment must be even across millions of kernels.
Inside the chamber, humidity is carefully adjusted. The goal is not adding water, but regulamastless hands, gentle movement prevents moisture pockets from forming. If moisture remains uneven, a kernels will. Sensors monitor internal moisture indirectly through bulk behavior. Once kernels leave this stage, the system adjusts humidity and exposure time automatically. Overconditioning creates surface moisture that conditioned kernels look unchanged, but behavior is now fixed. Their ability to build steam pressure has been set. From here forward, moisture is no longer adjusted, only protected. Every remaining step depends on this.
After conditioning, kernels move into oil coating. From this point forward, moisture will no longer be adjusted, only managed indirectly.
Oil is applied in precise quantities. Too much oil traps moisture incorrectly. Too little prevents even heating during popping. Tumbling spreads oil evenly across millions of kernels. Uneven coating leads to uneven heating that causes constantly. Seasoning is added after oil reliably. If seasoning absorbs moisture here, oil acts as both heat conductor and adhesive. This combination defines how moisture will convert to steam later. Excess seasoning is removed to prevent moisture pockets. Once sealed, any imbalance stays trapped inside the bag. At this point, kernel behavior is largely fixed. The remaining steps will only preserve or damage this balance.
The bag is not passive packaging. Its material controls how microwave energy turns kernel moisture into steam.
Bag shape determines steam circulation. Once formed, this geometry cannot be changed or corrected. Each bag receives a specific kernel mass. Too many kernels absorb heat unevenly. Too few.
Final flavoring is introduced carefully. Any moisture interaction here is sealed into the bag permanently.
Before sealing, everything must align exactly. Misalignment leads to weak seals that leak moisture over time. Weight checks confirm that moisture-bearing components are correct. Errors here cannot be corrected after sealing. From here, the system commits. Once sealed, moisture behavior is locked for the product's entire shelf life.
This is the final moment before commitment. Once sealed, internal moisture can no longer be adjusted or corrected.
The seal must close evenly across the entire bag. Any inconsistency becomes a long-term moisture leak.
Heat and pressure fuse the bag layers into one structure. If temperature or timing is wrong, cooling locks the seal's structure in place. Rapid or uneven cooling can create microscopic gaps. Inspection looks for defects invisible to consumers. Even the smallest seal flaw will slowly destroy popping performance. Rejected bags cannot be repaired. Once moisture integrity is compromised, the product is unusable. Only intact moisture systems continue forward. From this point on, the factory can only
After sealing, bags are still thermally unstable. Cooling begins to prevent moisture from condensing inside the package.
Cooling is gradual by design. Rapid cooling forces moisture to migrate and settle unevenly. Inside the bag, moisture slowly redistributes. This balance determines whether kernels will fix. Airflow prevents condensation from forming on the bag interior. Sensors verify that bags reach equilibrium. If this step is rushed, defects won't appear until weeks later. Once stabilized, internal moisture behavior is locked. Nothing downstream can improve it. From here, the factory only checks results. The process itself is already complete.
Quality control begins with random sampling. These bags represent thousands more already sealed and shipped.
Testing uses controlled microwave conditions. This removes consumer variability and isolates factory performance. Popping reveals how moisture was preserved. Steam pressure exposes every earlier manufacturing decision. Volume indicates how efficiently kernels expanded. Low volume signals moisture loss that cannot be corrected. Unpopped kernels are permanent failures. They show where moisture or structure was lost earlier. Seals are inspected again after heating. A weak seal may survive storage but fail during popping. Results determine whether entire batches ship or stop. By now, success or failure is already locked in. Individual bags are grouped for protection and transport. At this point, the factory can only prevent damage, not improve quality. Cases prevent direct exposure to ambient air. Even sealed bags degrade faster when physically stressed. Once closed, cases act as a moisture buffer. This layer slows environmental damage during storage and shipping. Labels guide logistics, not product performance. Moisture behavior is already fixed inside every bag. Shrink wrap stabilizes cases during movement. Crushed packaging increases the chance of seal stress over time. Srunit. Robotic stacking minimizes impact and compression. Uneven stacking creates pressure points that dampen units. From here, the factoring's role ends. The product's fate now depends on storage conditions.
Transportation exposes products to uncontrolled climates. Heat and dryness slowly pull moisture from sealed systems.
Warehouses rarely control humidity tightly. Moisture loss happens gradually and invisibly. Every day on a shelf slightly alters internal balance. There is no warning when performance begins to decline. Rotation keeps product moving, not improving. Time only reveals earlier manufacturing decisions. By now, every outcome is predetermined. Distribution simply delays the moment of truth. Retail storage offers no moisture protection. The factoring's work is either holding or failing. Once on the shelf, nothing changes inside the bag. Only the consumer will discover the result.
At home, the consumer changes nothing. The sealed moisture system created in the factory remains untouched.
Microwave energy targets water molecules inside each kernel. No moisture means no pressure.
Trapped water turns into steam. This phase change is only possible if moisture was preserved earlier. The kernel's hull acts as a pressure vessel. Any earlier crack or moisture loss prevents this buildup entirely. When pressure exceeds the hull's strength, the kernel explodes into foam. This transformation happens once. Successful popping means moisture survived months of storage and transport. The factory's decisions held all the way to consumption. Every unpopped kernel tells a history of moisture loss or damage. The failure happened long before the microwave was ever turned.